Thank you so much for coming to our talk, particularly since we're competing against Venkat, so that's awesome that you all came to ours.
What were you all thinking? Just kidding.
Welcome to Who Needs Batch? Let's go to this next one. Who are we? I'm Gunnar Hillert. I'm a committer on the Spring integration project, Spring XD, a little bit of Spring Batch. I'm heading the Atlanta Java users group, organizer of the DevNexus conference. So if you like this conference, check out ours in February. 1,700 people showing up for that one. So that's the plan. And yep, my Twitter account, Twitter handle. Occasionally I'm blogging, so check me out. And Michael.
I'm Michael Minella. I'm the project lead for Spring Batch. I also contribute to some of the Spring Cloud stuff, Spring Cloud streaming, Spring Cloud data flow that they announced last night. I'm working on that stuff. I'm also a member of a podcast, Java Off Heap. If you want to hear about if you want to listen to a bunch of guys in a bar complaining and BSing about Java and stuff on the JVM and things around that nature, check us out. We just had our most recent episode came out yesterday.
So we don't watch too much TV.
No.
Okay, about us?
So two things really quick. Number one, please ask questions during the talk. It's surprisingly boring talking at you guys for 90 minutes, so any dialogue helps us. But we also did have some questions to start this off. Specifically, a quick show of hands. Who here is doing batch processing of some kind? Cool. Nice. Are you guys all looking to get rid of it, given the name of this talk? So how?
Who's using Spring Batch? Let's put it that way.
Very good question. Okay.
That's
about the same.
Yep.
Close to the same. We'll get to all you other guys in a minute. All right. How many people here are using Hadoop of any kind or big data with that batch processing? So most of the batch processing being done is like the traditional enterprise stuff. Yeah. The traditional enterprise stuff. Okay. Fair enough. Just want to know what we're talking at. Okay.
So all the demo stuff we're doing here tonight, besides colorful slides, it's hosted here on GitHub. So should be out there. We'll tweet about it later on as well. So just in case you miss it. And we have an announcement. Actually, I should scream it, right? We have an announcement that we have kind of a disease in our industry, right? It's called Objectivius Genome Syndromus, shiny object syndrome. We just like new stuff. Fortunately for us, we're in the Java world. It's a little slow, but I mean, go into the JavaScript world and the client, you know how insane it has become of always chasing the latest and greatest and latest whatever. So it makes us, however, also to innovate. So keeps the pressure on, do better, improve, and we'll also talk about the road to recovery. So basically, we want to cover a whole bunch of things in this talk. Talk about all this, all the, not necessarily call it hype, but all the shiny stuff, and then basically put it into perspective of where we are. So all the cool kids these days are doing stream processing, right? So I mean, doing your Sparks, your all kinds of other stream processing stuff out there. So there's a whole bunch of solutions out there. Some of this, fits into our ecosystem. Let's say Spring XD or Spring integration. However, then also have your, Storm. That's pretty much where everything started. Spark, Samsar. In this demo, in this presentation, I'm going to show a demo on Flink, and there's a couple of other solutions as well.
This was an actual talk given at Strata London earlier this year. I don't know if you can read the title. It says "Say Goodbye to Batch." This talk is essentially a response to that talk. Was given by a Google engineer who was introducing Google Webflow or Web Data Flow at the conference, and he then proceeded to spend the next 40 minutes talking about microbatching. claiming that you could accomplish the same things you can in batch and streaming. And we're going to kind of explore that idea a little bit today.
And, you know, in all fairness, batch has been around for a long time, way before Windows come along, back.
Does anybody know what that is? What that's a picture of? It's called the Enoch. It was the first generally available computing machine. It came out, I believe, in the 40s. But it was a batch processing machine. Batch processing has been around since, or as long as general computing has been around. And so the idea that batch is going away is an interesting idea. I'm not saying it can or can't, it's an interesting idea that it's been around this long. So which is why we want to explore, is streaming to a point where we could actually replace batch processing with true streaming out of the box.
But it's still cool, so that's, you know, that's the main point. It has been around, but we make the point that it's, you know, still has very good use cases. But let's take a quicker look at this. And let's talk about what batch and stream actually are, and where the definitions are, and where the differences are, because it's not all defined. You know, what we understand as batch, somebody else may have a different interpretation of that. And look at some common use cases, and then basically come to a conclusion at the end of this talk. Stream processing. So what is stream processing, and where do we do the?
You're fine. So let's define what stream processing and batch processing are for the case of what we're going to be talking about today. Stream processing, for what we're going to be talking about today, is really the processing of an unbounded set of data in an asynchronous manner. Typically, the elements are ordered in some way. Typically, it's a time series of some kind. The events are flowing through a stream processing system. But this is a rough definition of when we look at all of those logos before. That's the goal of each one of those systems to be able to do. Batch processing is a little more interesting in the definition because it really depends on who you ask. When you hear about stream processing systems trying to replace what batch does, you get definitions like this, which is from the Apache Flink definition, or documentation. Apache Flink essentially views batch mode as nothing more than a unique use case for streaming. So it's just a special streaming use case. We'll get into the more detailed aspects later about how they actually implement that. But it's interesting to think of batch as really just nothing more than a specific way of doing stream processing. For our definition, though, today, I'd rather work off of this definition, which is that it's the processing of a bounded data set as opposed to an unbounded data set without interaction or interruption. So the idea is that you kick off a process, it has all the data available to it, because it's a finite data set, it processes and then completes. The key differences in the definitions would be, number one, streams are typically processing unbounded data sets, so you don't know if there is an end or if there even will be an end, versus bounded. Batch processing typically has a batch to work with. That has two characteristics there. Number one, you have all the data readily available, and you can also have relatively state because you know when you're done. Synchronous versus asynchronous. Batch is typically synchronous in that you typically start a job and stop it. So there is that state that you're processing through. Whereas asynchronous, the idea of processing on the streaming side is just I got an event and I'm going to process it and move on. The last key difference is stateful versus stateless. Jobs are typically stateful. You typically have, again, it started, it stopped. You work the data through the different states within a flow of a job, whereas streams are typically stateless. What happened, or as minimal state as possible, I should say. The idea that the impact of that data from one piece of data through the stream shouldn't impact what happened, or what happens to the next piece of data, and so on. Each one is processed individually, and they should have no no side effects or ripple effects down the stream, if that makes sense. The state of streaming. So there are a ton of different streaming projects out there. Some of them are Apache. All of the ones on this slide are open source or freely available. So we've got Flink, Stream Analytics, which is the Microsoft Azure streaming engine. We've got Google Cloud Dataflow, Tygon, Pulsar is from eBay, SQL Stream, Twitter Storm, Apache S4. We've got Spring Integration, Spring XD, Spark Streaming, Samza, Espertech has a streaming API. So obviously this is a space that a lot of people are working in, right? It's interesting to note that some of these have already identified that there isn't a clear, you can't do everything on the streaming side, and they actually have a side that is dedicated to batch. So Spark Streaming is built on top of the Spark API, right, which is essentially a batch API. Flink has a specific batch mode. Spring XD supports Spring Batch jobs. So these systems are already identifying that you can't do everything in streaming, so we need a way to do things in batch. The state of batch isn't quite as exciting, but it is still a busy place. We've got Spark, obviously, Spring Batch, Apache Flink. You could argue Uzi is a batch framework of some kind. MapReduce obviously brought batch back into being cool for a little while, and now it's being replaced by Spark. Easy Batch is a batching framework that's available, as well as JSR 352, which is the standard batch implementation for Java in general. So why the push to even move off of batch? When I asked the question earlier, if you guys are looking to move from streaming to batch, I got a bunch of head nods. What is the problem you're trying to solve that batch doesn't? Real time, so latency in general. Anything else? Yeah. So better resource utilization with streaming versus batch? Okay, that's one. Okay, more even utilization, okay.
Business hours processing so you can get better support. At night something went wrong and you have to fix it in the morning.
Okay, that's kind of a latency though too. It's whether or not the latency between catching the error versus, it's not a processing latency, it's a process latency, right? Anything else? Okay, I'll be honest with you, I have not heard anybody throw out the resource evening, because usually we've seen it the exact opposite, is that you want to better utilize your resources with batch than streaming. The one thing that we do hear over and over though is latency. The idea of we need those answers faster. We need them quicker, we need them more real time. We want to be able to make real time decisions. Those are all, that is the common thing we hear in people that are replacing batch systems with streaming systems. And it makes sense. We live in a real-time world. We live in a world of Twitter and Facebook and you know, Donald Trump sneezes and it's the front page of CNN. So that's the kind of world we live in, and everybody expects that type of feedback for everything. So it's reasonable to be attempting to minimize that latency within your systems. So what does the end of batch mean, though? So obviously we want to limit latency. That's kind of the goal here. But in order to completely eliminate batch, we need to be able to do it in an enterprise-grade way. So that means we need to be able to handle things like robust error handling. We need to be able to integrate with existing systems. Those are things that we'll talk about and we'll look at, but just limiting latency by itself typically isn't good enough of an answer in all use cases to move from batch to streaming. So let's look at some common use cases. First one that everybody thinks of within the batch world is ETL, right? So moving data around, whatnot. And let's actually take a look at an example of that, which is moving data from a database to HDFS. So we're using big data here just because it's cool. But the idea of moving data from a database to a database or files to database, this type of job applies regardless, right? You want to do yours?
Yep, sounds good. So basically, we have a few demos sprinkled throughout. I'm going to start with Apache Flink, actually, as a demo. Just to give you a few points of Apache Flink itself. So Apache Flink, basically, it's a streaming data flow engine, and it kind of like aims to unify stream and batch processing. Interesting, though, at least for the time being, it has still separate APIs for which is a data stream API and a data set API, which is basically the batch API for since you have a dealing with bounded data sets. That's also part of what I'm going into in the demo. Then, of course, you can also run it on, in various environments, local, remote installation, yarn, etc. And then basically you have multiple components, APIs on top of that, going into Hadoop, machine learning, etc., etc. There's something for Google Dataflow, etc. So that's kind of like just a very quick overview. I just want to let me go into the code itself to show you what the demo does. So basically, in our demos, we pretty much took the data set from Stack Overflow, and we basically imported that into MySQL. So basically, the demo is basically taking the information out of MySQL and shoving it straight into HDFS. So that's kind of like our little demo. On the Flink demo, I also have a little bit, I'm counting like the top used tags I'm using. I'm using a little subset of the Stack Overflow data, so it's kind of like for demo purposes. But if you really want to run it, it's actually a really nice data set. I think it's like 35, 50 gigs, whatever, compressed.
So yeah, it's, Stack Exchange, which is the parent company of Stack Overflow, they provide all of the publicly available data on all of their properties available for download. There's a link to it in our README. You can, before you used to have to download the entire torrent with all of the properties together. Now you can individually pick which properties you care about. Be aware it's a lot of data, but it's a really nice data set, and it's rather nicely structured in that it's got a simple data model. It is XML, don't blame us. But so the data set we'll actually be using for this, because the Stack Overflow in itself is just too long or large to run in with us standing here. It takes, to do these types of jobs, takes minutes to almost an hour. For the full data sets, we're actually using bicycles.stackoverflow.com.
I'm just wondering, can you maybe lower the font size just a notch?
Oh yeah, because of the horrible resolution. Give me a sec. Actually, yes. Quite as big. A little better.
All right, that should work. Okay, so admittedly, simple example, but just give you a feel of what Flink does. Everything runs in a just a void main method. The interesting thing about Flink is you basically start out with an execution environment. The nice thing here is that you're basically, when you get the execution environment, you can either get specific execution environments, or in this case, I'm fairly generic. So basically, depending on where my app is running, I'm getting the execution environment specific for that environment. So in this case, I'm running it, if I'm running it just from within my IDE, it bootstraps itself locally, and it just works. At the same token, the build process for the demo, and you can check that out on the GitHub code, is when you build it, it basically just generates a jar file, which you then can submit into basically the Flink cluster, and it gets executed there. Basically, what we're doing here is in Flink, you're basically creating data sets. And those data sets, they have a concept of using tuples. So you basically, as a very basic data structure, you have tuple 1 to, I think, 25. The advantage here is that they're using their own serialization framework instead of reusing something else. At least for those tuples, you basically operate, they have a much tighter integration into the serialization process, and that's where they claim also speed advantages. But you could also use POJUs. So for the demo though, basically table-based data, I just used the tuples, which admittedly gets a little wordy on some of the stuff. So basically what we're doing here, we're building a data set, we're getting the execution environment, we're creating an input, and here we do an input format, which I basically kind of like abstracted out. Same class. What I'm using here is basically a JDBC input format. So they have basically a couple of input formats available to read from flat files, etc. And JDBC is another option they have. So you have a little build-up pattern here. I'm setting my database properties, finish, get the database input, and then I create my input, provide some basically type information on that, and then I can go about actually, in this case, I'm writing it back out. So it's fairly straightforward in that regard. So I'm basically in here again. You basically output it. You have the option to actually directly, if you go on here, there is, I believe there is, yep. So basically there are a couple of predefined methods out there to write a CSV, format a text, etc. It has basically similar to what you used in Spring when you address, basically you can, based on the prefix in your URLs, you can basically write to either the file system and or HDFS. So that's an option. In case of CSV, even though there was an option for CSV, it was kind of interesting. I had to actually create a manual output format as I wanted to ignore null values that may happen in the data set, and the default didn't give me that option. So I had to create an output format. And wait a minute, where do I? Oh, I clicked on the wrong thing. Get output format, that's what I wanted. So basically, in the demo, to just make it maybe even a little easier for you if you want to play around with this stuff, may not have a Hadoop cluster running or a local Hadoop installation. Well, it's fairly straightforward, but just to make it a little easier, you can submit the demo also with the flag local FS. And then I'm basically just writing out to the local file system. But basically, the difference being here that just file colon and then HDFS colon, that makes a difference where you write to. Then I'm defining my CSV output format. I'm setting that null values are being accepted. I'm setting the write mode that I'm overwriting, and just return the output format. And that's basically all that is necessary to get stuff into HDFS. But as you see this, I'm doing it multiple times. So basically what I'm doing is, in the execution environment, I'm basically setting up my execution plan, basically. I'm basically setting all those things up I want to do. And then at the very end, I then basically have my, what is it? I'm just calling execute and I'm executing the demo. So I'm doing this for a couple of those, for each of those tables. The more interesting one is then basically when I do the top 5 tags. So basically what I can do in Flink is basically you have a type safe API to do then the map and reduce operation and all that kind of stuff on those data sets. So in this case, for example, I want to group all the where's my query data set, post tag, post tag, get output format, select post, yep, so basically I have a post ID and the tag ID. So I'm just creating and grouping on the tag ID here. And then, where is it again? Losing track here. Yep, group. Then I'm reducing it. Reduce the group here. I could have used a projection here itself to get rid of some of the data. Basically, I'm returning a tuple of just the tag ID and then just a count one. I can then sum that up. So I do another group here, sum that up, so puts it all up. I'm ordering it then based on the descending count of tags. So at this point, I only have basically a list of tag IDs and the value for each tag. Would be kind of cool to also get the tag name actually. So since that is in a different table, I need to do a join basically. So in this case, I have the ability to select which. If you're wondering what those numbers are here, that is basically I'm operating on tuples. So I have tuple 1, 2, whatever, and basically I can address the values of those tuples directly by just using numeric values here, which works fairly okay. So basically what I do then is, basically I can, using the API, dataset API, I can join on those data sets I'm retrieving. So I could technically use a data set from, in this case I'm just using JDBC, but it could technically be like I've taken one from JDBC, I'm taking another flat file in, create another data set, do a join similar to what you do in your SQL queries, join on those data tags, do a where clause here, basically where the tag ID matches what I have in the tag table, and then do another projection. So I'm only getting back the tag name and the count of that operation. So that's the idea, and then at the end I'm just spitting it back out and writing a CSV file, which basically gets pumped into HDFS. So let's make sure that actually that stuff works. Well, I can actually, as I mentioned before, I can run it in two different ways. One is, what did I do here? Okay, cool. Yep, just ran. Should be done. Let me just check on where's my HDFS. Yep. We spit it out into Flink. My data sets. And just to make sure that everything works fine. Not necessarily the best format for CSV, but just for the idea, so it spits it out. Let's take a quick look at the top 5 tags. That one was actually kind of interesting. I'm not sure. One thing I noticed with Flink, it's still under, even though the project started as a research project by 3 Berlin-based universities in Germany in 2010. It's still under fairly active development. I think the company behind it, Data Artisans, was only formed last year. Yeah. It was previously known actually as Stratosphere, so if you come across pointers on that, there's some research papers on there. So that's Stratosphere, and then it became an incubator project on the Apache Foundation. So it's very active development. So that's what I'm blaming it for. Maybe I'm missing something obvious here as well. But the notion is basically that when I wrote my top 5 counts, I should have ended up with a top 5 tag CSV file. But for some really weird reason, it created a directory. But the data is still in there. So if I go in there, ls, so I have that, and then it should actually be right down here.
FYI, we're not getting about your last 2 lines or so.
So we still have the count basically. So everybody likes Android phones apparently. So that's basically like a quick example you can do in Flink to get those counts. However, just one more thing. I run it within my IDE. I also have it under, where is it here? Too many. Wait a minute, which one is my? Yep, here we go. So you can also basically run it on the Flink, in the Flink environment. So basically, just to get it up running, it's just could be as simple as basically just unzipping it and running it, but it then becomes basically an execution environment. It also has a dashboard with it. So simplistic, but at least you see what's going on. Even responsive, that's nice. Execution environments, history should be in there. Let me just run this. So basically, the way you interact with it is just having the Flink command, run it, and that will basically submit that jar file over into the cluster and execute it. So one thing about Flink is it actually under the covers, it basically uses akka and also provides parallelization of not just across your cluster but also of your collection. So there's a whole bunch of ways to also control the parallelism you want to imply across the jobs you're going to execute. Yep, executed, data should be there, and we should have something on the job history. I should have provided a name, I guess. Okay, here we go. And then it provides you a little bit of steps, what's going on, what has been executed, etc. So so that's kind of like my very quick overview of what Flink does, how you can get started, and that's basically one example of it. However, we talk about in terms of batch environments. While this is actually nice, you had some nice APIs, had some issues with the generics. For some reason, I had a whole bunch of warnings around there. I wasn't necessarily able to figure out how to work around those, except in suppressing them. The thing I want to have in batch is, however, also error handling, restartability, etc. So there is some state management in Flink, and that's, I think, in the late, since March, but that's only in the streaming API. So my understanding, I might be missing the point here, or the information. There was nothing that indicated that it supports at the present time any type of restart on the batch side. So you want to have, when you have Spring Batch applications, you want to basically, if an error happens in the middle, you want to have restart the process, multiple retry. You can even define policies, etc. around that. It didn't seem to have that. Similar to later on, we have demos. In batch you can do notifications and all that kind of stuff. So there's many cases it might be documentation issues. It's very fresh in that regard. While there are very good video tutorials and the reference doc is fairly nice, it doesn't seem to. I didn't have too much stuff on Stack Overflow. Let's put it that way. But check it out. certainly, certainly interesting. With that,
Teacher, quick question.
hmm?
Quick question.
Yes.
So to get Flink, so you ran the Flink as a standalone out of the ID to start with. Running this in a production environment, what would you have to do to get set up? Like what would is running Flink like that okay in production, or do you need some type of cluster?
You can run it on.
or something?
You can run it locally as a standalone application. You can run it in your YARN environment. I think Apache Test was another option they have in there.
But is that standalone option that you showed us, is that an option for production?
I believe
a realistic one?
I believe so.
Okay.
You can cluster it that way, but don't quote me on that one. So I'm basically just a step ahead of you. So you know, we're doing some research here, so figuring stuff out, how it fits into our stuff. Yeah.
Cool.
So with that, we want to show some restartability.
I don't know if I'll show it, but I'll show the difference in batch. One interesting thing, obviously Spark has got a lot more press than Flink. It's been around longer. It's actually being used in some enterprises and whatnot. One key difference between Flink and Spark is Spark, if you're familiar with it at all, is built around the concept of an RDD, or resilient data set. Resilient distributed data set, or something along those lines. But essentially Spark is built around microbatching in that it processes groups at a time. Flink is true streaming where it processes items individually. That is their big thing, is that they don't microbatch unless you specifically ask for it. So thanks, Gunnar, for doing the Flink stuff. Let's flip over to this same use case, though, in batch. So on the batch side of things, I'm using Spring Batch for this, surprise, surprise. I just wrote a simple boot application. You can see on the boot side of things, I have a Spring Boot application. I am auto-wiring in one thing, which is, one sec. So the only thing I'm auto-wiring in is the configuration for Hadoop. So the Hadoop configuration that allows me to connect to file systems and whatnot, I'm auto-wiring that. That's provided by Spring Boot Hadoop. So that's an extension of the Spring for Apache Hadoop project. That bootstraps it basically gives you all the niceties of boot with all the stuff that the Spring for Apache Hadoop project provides. So I get this configuration object auto-wired in nicely. With that, I can build my file system. So this is the handle I use to grab onto the Hadoop HDFS file system. And then I've got this main class that you see in every Spring Boot application. Outside of that, I have some HDFS-specific writers. These are actually just copied over from Spring XD. I could have imported the library, but I was just doing this down and dirty. But so these are out-of-the-box stuff that's provided in Spring XD, if you wanted to do it that way. Or you can, like I said, you can just import the library. I've got domain objects here, so this is just an object per table. It's straight mapping, so you can see there's 4 different tables for this use case. There's comments, posts, users, and votes. Answers within the Stack Overflow world are the same thing as a post. It just has a post type that indicates that. I've got a JSON line aggregator, which I'm actually not using for this. And then an entity superclass that just has ID and version for the typical database ID and optimistic locking. I've got a general batch configuration, which is where I build. This is actually a duplicate. I don't even need that. So really the only thing I'm doing here is I'm building my job. So you can see I've got job builder factory.getJob. I grab an incrementer so I can run this over and over without having to pass in unique IDs. And then I'm just moving from step to step to step. So start, next, 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 and that's it. Oh, I'm looking at the wrong one. I thought that was weird. So sorry, I'm looking at the wrong one. That's the one we'll be running in a minute. I want this one because I'm actually running them in parallel in mine. So if we go to batch configuration, so everything else in what I was just showing you with is the same. The domain object, all that's all the same. But in this job, I'm actually going to run all the steps in parallel. If I can arrange this a little better. So what I'm actually doing is I'm creating a split, and then I'm going to create a flow for each step. And then each one of those flows will be run in parallel. So I'm actually going to, it speeds up processing, right? So I can actually import the posts, the comments, the user flow, and the votes all at the same time. Because for a database import like this, the IDs have already been generated. There's no referential integrity concerns that I have about this. It's literally just dump the data in the right format into the file system. So in this case, I build this flow that, like I said, orchestrates the split. And then I orchestrate my job itself simply by saying, give me a job, give me the row, or the incrementer. Again, this just handles the uniqueness of each job instance. And then I call start on the flow, and that's going to orchestrate the rest for me. So in each step within this job, each step actually looks the same. I've got a configuration for each one of the different tables. I've got a comment, a post, a user, and a vote. So if we take a look at any one of them, they're all basically the same. I'll start at the bottom where I actually build my step. So I create my step. I set my chunk size to 1,000 in this case. I've got a reader, a writer, and I call build. The reader is the JDBC paging item reader. This is a reader out of Spring Batch, out of the box. All I'm doing here is I'm passing in a data source, the fetch size, which typically is helpful to match the fetch size with the chunk size for performance reasons. I've got a query provider, which is going to generate the query for each page that I ask for. Since this is a paging one, it's going to run a SQL query to essentially get 1,000 record chunks as we go along. And then the row mapper to map those records to objects. So if we go to the provider really quick, whoops. We're using MySQL for this, so I'm using the MySQL paging query provider. I provide my select clause, which in this case is the equivalent of a select star. From comments, and the sort keys, in this case I'm just sorting by ID ascending. When you're doing paging, order is obviously important for restartability so that I can restart at the same. If I restart at the 5,000th record, if they're not sorted the same, that 5,000th record may be different, so I have to sort. The row mapper is about as basic as you can get. It's just take result set, insert into object, and that's it. All the other ones look, like I said, exactly the same. So if we go ahead and run this, you can see the task executors are all executing their steps in parallel. And then if we go ahead and check back over in Hadoop, there's a new directory. Who needs batch? And you can see each one of the tables is imported over. The stuff, the readers and writers I'm using out of XD, like I said, you can just import these as a library as well. But these support rollover as well. So right now they're rolling over at, I think, a meg, 10 meg, something like that. 10 megs, is that right? Give or take. So that's why they're numbered and you get that difference. So if I do a quick, oops. You can see there's the data. But the interesting thing with Spring Batch is if importing data like this, think about that post body. That's got HTML free-form text in it. If I had any errors, if I was doing validation on that, if I was handling any of that, if it fails, the job stops, and I can fix the data and restart it, and it picks up exactly where it left off. On the Flink side, frankly, in most streaming solutions, that capability isn't there. So you can I'm not saying you can't do it, it's just you have to custom code around that, right? You could add in your own try catches for everything under the sun and handle those by hand. But with Spring Batch, I don't have to write any additional code to get that functionality. Does that make sense?
And you have the ability to basically, hook in listeners, for example, if something like an error happens, emits, you need then submit that into other processes that notify people via email or something else, or need to update other systems. You can easily do that with whatever Spring Batch provides.
Yep.
Or any other policies around it, right? I mean, skip, you want to skip it, you want to retry, those type of things.
Yep. We're not saying that streaming doesn't make sense for ingestion use cases. In fact, it can be very helpful in ingestion use cases where data integrity can be compromised a bit. Think about ingesting Twitter into HDFS. If I miss a tweet, it's probably not the end of the world, right? So let's take a look at an example of that. For this one, I actually have a Spark example that we'll take a quick look at. So here for Spark, I'm just running it in plain, straight Spark streaming mode. Without a Spark cluster, I'm running it all standalone. But so here, we get our Spark configuration. So that essentially provides the base bootstrapping of Spark. I set the URL, which is just local. I set an app name and validate settings. Then I get a Java streaming context, so I'm actually going to be using Spark streaming for this. So I pass in the URL, the app name, and the duration. So the duration is essentially the windowing. So this goes back to Spark's microbatching. This is essentially saying each microbatch will be a second long. I have to pass this configuration. So Spark Streaming has this Twitter utils that will provide a Twitter source for you. It uses Twitter for J under the hood. And so this configuration builder essentially just grabs my authentication information for Twitter out of system properties and wraps that up nicely so I can just pass it in. And then all I'm going to do is tweets.map, just return it again. .dstream, so this takes my streaming stuff and essentially then brings it back to regular Spark, and it creates the RDDs for me again. And that's what I can then persist to a file system, save as text files, and since it's a HDFS : / it's going to persist to HDFS. To kick this off, you just do the context.start, and then you can either, if I leave this off, it'll run forever, or in this case, since I'm standing up here and you guys don't want to sit forever, I'm just going to run it for 10 seconds. So essentially what this is doing is it's a stream, but it's creating micro batches and taking those and persisting them to HDFS for us. So that was 10 seconds, so that's done. So now if we go back to here, and probably be, oops. Now there is a Spark directory. Oops. Twitter. Grab any one of these. These are essentially each one of the windows. So I can grab any one of them and we can look at the tweets that were recorded within there. So we can grab, let's say, this one and take a look at it. I will warn people before I press enter on this. The Twitter source that comes with Spark is the fire hose. So I am not responsible in any way for the language or what these tweets actually are. There is no filtering involved in this. We had some interesting stuff just when we were testing this a minute ago. Fetish shoot for my members, yeah, it's a, yeah. But you can see that there's You can see that there's Twitter data there. Yeah, and you can tell it's real Twitter. It really came from Twitter. But so any questions on the ETL specific use case before we move on to other ones? So data science is another very common use case or scenario where you see this mix of batch and streaming modes. It's very common to do batch training with predictive models. An example of that is, did anybody here go to my talk yesterday on the connected car? See one or two hands? So the connected car talk yesterday, we use data science to predict where you're driving to, and then using that historical information, we then predict the range of how far you can go on your current tank of gas. So essentially, historically, if you, at your trip to work, you get 25 miles per gallon. If we can predict you're going to work, we can then extrapolate out based on how much gas is left in your tank, how far you can actually go. So can you make it to work and then pick up gas afterwards? You have to get gas on the way. It's just a much more accurate way of calculating range prediction than what's in your current car, which is essentially take the current miles per gallon, which fluctuates all over the place, and multiply that times the gallons left. This is the diagram of that entire connected car system. I don't want to go through any of it because the part that I left out yesterday, and the interesting part is actually that. So offline, in between runs, basically what happens with the connected car is we record sensor data from the vehicle as it's driving into HDFS, and then periodically we'll run a batch training job that will actually generate that predictive model for us. We're using Spark for it. It was written by some data scientists out of Germany that we work with. But it's important to note that we're using Spark, not the streaming version, but the batch version of this. The reason for that is because the way data science works, a lot of the models a lot of the algorithms that are in the data science space, while there's a lot of work in converting those to streaming, they're still not there. There are streaming approximations that exist. So like we use an algorithm called k-means clustering to cluster the journeys to identify groups of drives together. So these are all your drives to work. These are all your drives to the grocery store and so forth. That algorithm, there are streaming approximations that will get you within a certain threshold of that, but they're not nearly as accurate. And the breadth of algorithms implemented on the streaming side aren't available. Another example of batch use cases is workflow orchestration. Whether you're doing this in the enterprise world, kicking off multiple jobs or sequences of jobs, or in the big data world, this is kind of the guy everybody knows and loves, Uzi. So orchestrating workloads on Hadoop, let's say. This is another example, though, where batch processing really shines, given the fact that it's stateful. So as you move through batch jobs, you're typically moving from state to state to state, which you don't really have that concept within a stateless stream, right? Let's take a look at an example. So this is a flow that actually was published in InfoQ as an article. It was an example of an Uzi flow. I've re-implemented it in Spring Batch just as an example. But essentially, the use case they're doing here is, let's say you are a company that receives GPS probes from vehicles out in the fleet once an hour. So once an hour, you get a file dropped onto HDFS. That's 24/7. Every 24-hour window is within a directory. So each day I create a new directory, the probes go there. I should have 24 files per directory when it's time to ingest them. What this flow essentially does is it gets the info of the available directories that are out there. For each directory, there's a sub-process that is on the next slide. It parallelizes that out based on the number of directories we're working with, and then figures out the results. What it does for each directory is first it checks the age and the number of files. So how old is the directory? In other words, is it today's directory or not? And the number of files. So if it's older than today, does it have all 24 files? Because if it doesn't have all 24 files, something is wrong. If it does fall within there, so yeah, the first check is, does the directory exist, and is the age less than 1 or the number of files less than 24? Condition 2 is the number of files is greater than 23 and the directory age is greater than 6. So basically, we're looking for all the directories that are less than a week old, not today's, that have 24 files in the directory. If they fall within the date range and don't have the right number of files, we're going to send an email to the provider saying, hey, where's our files? You owe us data. If it does have the right number of files, we'll ingest them. In this example, I'm just going to move them to another directory. And then we'll archive the old directory, or the old data. And then if it doesn't fall within either one of those two use cases, the job just ends. We just don't do anything. Does that make sense? Let's look at that in Spring Batch. I can kill Spark. I can kill. Workflow somewhere else. So again, this is just a Spring Boot application. I've got this workflow application, which, starting from the bottom, you've got the typical Spring Boot public static void main. I've got enable batch processing like I did before. I've got a Hadoop configuration just like I had before. I don't need any of that actually in this. Then I've got the main workflow, which is essentially the first diagram slide I showed. So in this case, I'll start at the bottom. I've got the job, and the job is actually going to run a partition step. So I'm going to partition by the directories that are available. So essentially I'll create one partition per directory, and then those partitions will be parallel or processed in parallel. So the checks of whether or not we should process, should we send an email, ingest the directory, all that for each directory will be processed in parallel. So moving up to partition step. This is how you configure a partition step in Spring Batch. So within partitioning within Spring Batch, there's two main components. There is the partition handler and the partitioner. Partitioner is responsible for knowing what is the data I'm dividing up. So in this case, it knows how to read directories, it knows the conditions I'm looking for. And the partition handler knows essentially how to run steps within the grid I'm working with. Am I using messaging to communicate with slaves? Am I using threads locally, etc.? So in this case, I'm using the thread version of the partition handler, so task executor partition handler. So I'm going to execute all of my slaves in parallel in threads in a local JVM. So I build my step, main step, partitioner, ingest flow. I create my partitioner, create my partition handler, call build. My partitioner is going to look in a directory called probes on HDFS. And essentially, it's going to get all of the directories in that directory, so all the children directories. And it's going to return a partition for each one of those directories. So starting off, we've got three directories, dir 1, dir 2, dir 3. Dir 1 and 3 are empty. If we look at dir 2 really quick, there's 24 files. So in theory, we should get, directories 1 and 3 are old enough where I should get an email for directory 1 and 3, and directory 2 should actually kick off the processing. So this is the main flow. So this is essentially the Java configuration for the parent, if you will, or the first slide of that diagram. The workflow configuration is the piece that actually has what was in that second diagram. So in this case, starting off at the bottom again, I'm actually using child jobs for this, so that I can actually, since I'm parallelizing a multi-step process, partitioning individual steps works great for partitioning a single unit of work. But in this case, I actually have a flow of ingest and archive that I need to step through, plus a decision whether or not to do it at all. So because of that, I'm actually using child jobs as the parallel process piece. So I'm building these flows, or I build this flow that essentially, I start off with a decision. The decision implements the decider interface that Spring Batch provides, and all it does is it handles those two checks that you have to do. So is the directory old enough? Are the dirt files there? If they are, go ahead and process it. If not, do the appropriate thing. So if the input exists and the conditions are right or are not right, or if it doesn't exist, sorry, and they aren't right, we end. If the conditions are right, we ingest. If the directory is there but the conditions are wrong, we send an email. Once we have the decider, if we send the email, we go to the email step, which is here. And all that's going to do is execute this tasklet, which simply sends an email. Nothing fancy or complicated there. If we do the ingestion, we run this ingest tasklet, which all this is going to do is, there we go. All this is going to do is it's going to create a directory under probes that is named the directory I'm ingested. So in this case, we expect /probe/dir2 ingested. And it's going to just concatenate all the files together into one file. For the record, each file just has a single word. It's the word version of the numbers. So 1, 2, 3, 4, and so forth. Once things are ingested, then it'll go into the archive where it'll archive things. And then it'll end. So let's go ahead and actually run it. Let's go ahead to... So you can see that the ingestion is happening there. So we executed the email step twice, once for dir1 and once for dir3, and then we did the ingest step for dir2. You can even see the path that we created. So we'll go ahead and take a look at the path we created. You can see there's now this file, probes dir2 ingested.out. If we tail that, there's the contents of each one of those individual files. I trusted the network here enough to actually send real emails. And you can see directory dir3 had no files and dir1 had no files. So you can see the email sent as well. So how would this be done via streaming? Is there an option? Not that we're aware of. Doing this type of orchestration is just something that, it doesn't even make sense. So the idea that you're going to orchestrate workloads like this, it doesn't even make sense to be doing it in a streaming mode. You could have slaves that are listening and do these things asynchronously, orchestrating them via messages and whatnot. But the fundamental processing here is still stateful. So you're still working through a state, and you're still working through that flow that batch provides. The last use case we wanted to look at is non-interactive processing. A lot of people don't even think about batch specifically for this type of processing. They don't even think of stream processing per se. The issues you run into are the same as ETL, in that you still need the error handling, you still need the retry and that type of stuff. But this is less about this is less about transitioning from state to state and more just about data durability and things like that. In a previous life, I worked for a security company, and I was part of the vulnerability scanning team. So we actually maintained a vuln scanner. So in relation to that, I've implemented a port scanner that we can use to scan a server. The reason that this makes sense in the batch world is if you think about if I'm doing a vulnerability scanner or a port scanner for PCI compliance. I've got 65,000 ports that I need to scan. I can't beat up the server too badly because it's a production server, right? But I need to make sure I get through all 65 ports Otherwise, I can't certify that they are secure. So I need those error handling. I need the state management of being able to understand how far did I get through that scan, and if something went wrong, being able to restart where we left off, in order to be able to effectively accomplish the use case. The code for this is actually pretty straightforward. If you're really interested in this particular use case, there is in my personal GitHub repo, there's an example of this that runs on Cloud Foundry and does the distributed partitioning. So if you're really interested in batch, go ahead and check out that particular repo. But I just threw this together really quick as a port of that. So this is, again, your typical Spring Boot application. Let me go to the actual configuration. So the job is a 3-step job. I'm going to load the ports into a database. So essentially this is going to create a record per IP and port combination. So there's a targets table in the database. That's where I'm going to keep track of what I find as I try to connect to each port. The next step is I'm going to scan the ports. This is another partition step where I'm going to divide up the ports so I can be hitting more than I can hit more than one at once at least. Then I'm going to generate the results. In this case, I'm going to generate an XML file that lists out the ports I found that were open, as well as any banner information. So if you've ever connected via Telnet to something and it kicks out the banner saying who owns it and the versions and all that type of stuff, I'm recording that information if it's available. So in the load ports, all this is doing is it's running this tasklet, which is literally just going to loop through however many ports I request and add a record into the database. So I'm literally just using JDBC template, insert in batch mode, 1 record per IP port combination. For the master scan results, like I said, this is another partitioned job. So the actual interesting thing here is the scan port step. That's the step that's being run in parallel. So we've got a reader, a processor, and writer. The reader is going to read each record out of that targets table. The processor is what's actually doing the scanning. So it's really straightforward. It's just using java.net.sockets, trying to connect to the port. If it connects, it's going to save off anything it can read off of it. So get the input stream, read the line. If it gives me anything, it may or may not, don't know. And then I'll stick that back in the database and identify that I have scanned that port. And then I've got the writer, which is actually going to do the writing of each piece as it's scanned. So in this case, I read a target, which is IP port. I read that, I process it by scanning it, and then I write the results. And then the last piece of this is the generate results, which is just using a reader and writer. The reader is actually the same reader that I used in the previous step, and then XML output writer is just writing an XML file with the data that comes back. So let's go ahead and run this. Hopefully the network isn't too bad. I've limited, so PCI compliance requires a full port scan of all 65,000 blah, blah, blah ports. I'm not going to make you sit through that. We're going to scan the low 500 ports. Is also because I don't want my boss mad at me because I'm scanning spring.io. Let's also run for a couple seconds. You can see the ports that are being scanned. They're being scanned in parallel. It's too low. Shoot.
Why does your spring.io security firewall even allow you to do this and get away with it?
It can't stop me from hitting ports, right? On a public facing website?
If it recognizes the port scan pattern, shouldn't shut it down?
Yeah, in theory. If I'm being blatantly obvious, sequentially going through them, I'm not being that obvious. Come on, man, really? All right, so this is going a little slower than I would like. All right, I'll come back to the actual results. I can tell you right now there's 3 ports that are open. It's 53, 80, and 443, DNS, HTTP, HTTPS, the things you'd expect to be open. And there are no banner, there's no banner information. So again, though, this is another example where because it's stateful, streaming doesn't make sense. If I were to try and scan a company where I'm given, in this case, think of scanning Microsoft, think of scanning Pivotal, think of scanning where I'm given a block of IPs. I need to scan 65,000 ports on every publicly available web server within that block. I can't just get halfway through, die, and start over. That just isn't an option. So I need to be able to maintain state. I need to make sure that those data guarantees are there. And I need to be able to handle the errors if something does go wrong. So in general, though, streaming does make sense where latency is a priority. So examples of the ingestion, the IoT use case that we use in the connected car, where that's the majority of the ingestion there is streaming. So is the real-time evaluation of the data science models. So we use batch training to generate the models, but then we evaluate those in real time via a stream, because that's how we then provide the feedback that you need real time. It's also makes sense when data loss is acceptable. So can I lose a tweet? Can I lose a packet from a moving car? Maybe. Can I lose a withdrawal from somebody's ATM? Maybe not. So those are things that are very important, and we can't risk losing those. Finally, unbounded data sets. Batch, while you can have a batch job that runs forever, it typically doesn't run very well. It's not a use case that batch frameworks are typically developed for. But there are cases, though, when it doesn't make sense. There are disadvantages of using it, though, which one is stream processing is typically highly complex. So you typically have lots of individual pieces, lots of different moving parts. Each one of the examples I did for Spring Batch, I would feel comfortable throwing in a production environment. It's a Spring Boot application that I could do java-jar, and it would run the same way in production as it does on my laptop. Whereas some of these streaming cases, Spark Streaming is a good example. I wouldn't run that Spark Streaming example as the java-jar with the Spark Streaming option in production. You have to set up a Spark cluster and submit it to the Spark cluster. And there's a lot more moving parts. There's a lot more infrastructure that you need to build a robust streaming option. As we've seen, error handling isn't very robust on the streaming side. The idea that a null pointer could crash my stream and then I need to reboot it, and what's happening while that data is coming in, that's just not a very useful way of processing. And the data guarantees aren't as robust. Most stream processing frameworks aren't transactional. So the idea of doing multiple updates or updates that are guaranteed typically aren't seen on the streaming side, whereas on the batch side, it's inherently transactional. Each chunk within at least within Spring Batch, and most of these other examples are transactional. You commit transactions, it's how it works. Batch is better though, where there's a finite data set, you need robust error handling, and you need data guarantees. So I can't afford to lose data that came through an ATM or via financial aspects, but I can afford to lose a tweet. So that's why streaming tweets is okay, but streaming ATM data may or may not be. Finally, where resources are concerned, streaming may not be the best option. Batch has historically been a better way of guaranteeing maximum resource utilization because you can typically schedule it. You can orchestrate it the way you need to and the way you have resources available, as opposed to streaming options where it's typically dependent on, or the resource utilization is dependent on external stimuli. So if I'm streaming tweets during the Super Bowl, I'm going to get flooded with data. So I have to be able to handle that, and I need the infrastructure to be able to handle that spike, even though that happens once a year. Whereas in batch mode, I could collect all that data and process it all and adjust my resource utilization based on whether or not, it's the Super Bowl. I can, run more partitions on the Super Bowl night and less the next day. The most important thing, though, is this shouldn't be an either-or question at all. It's when you combine the two together where you get the most power. The idea that you have to choose one or the other, and this particular use case is a batch use case or it is a streaming use case, really isn't 100% true. The best utilization for these technologies is when you use the right tool for the job. And so if we take a look at ETL v2, we can expand on that a little bit. So we're still doing the same import, MySQL to HDFS, but now let's say I wanted to kick it off via HTTP. Let's say I wanted to have an HTTP endpoint that I could post data to kick it off. So now the triggering of that is essentially via a stream. It's asynchronous. I can also, within Spring XD, attach listeners to the various, listen to queues to the various events that batch jobs kick off. So I can receive emails based on the status of the job. So if we look at how that works, we can see the combination of the two.
Yep, so basically we have taken the same batch job that we had previously of importing the data into HDFS and expanded and basically made it executable on Spring XD. Let me just open up the window. All right, so we basically still have the same batch job here. Let me just bigger here. So, it's basically what we still had before. Nothing really changed there. It still wraps up into a jar file, which we then upload to Spring XD as a custom module, and basically can integrate that into our setup there. So we basically set up the batch job, but then we can also tap into the batch job itself, basically saying, I want to capture notifications that are automatically exposed by Spring XD and act upon those, for example, to send email notifications out when the batch job completes, for example. At the same token, also, when I have the batch job set up, I can also have various ways to trigger that batch job. So, for example, if I want to get it trigger something from a file source, I can do that. If I want to trigger it via HTTP, I can do that. So I can use a wide range of adapters that are available for the triggering mechanism. So let me bring that up.
While he's bringing that up, one thing I wanted to mention is you probably saw the keynotes and the talks about the Spring data flow, or Spring Cloud data flow. With the code that's out on GitHub right now that is not data flowized, if you will, one of the beauties of that particular project, though, is in Spring XD 1.2, which is what we're using, while the actual jar file is a boot jar file, there is a slight packaging difference. With the new version, it will be the exact same thing. So what I can do java-jar outside of the context of Spring XD, or I can push it to a Maven repository and have it orchestrated by Spring XD, or Spring Cloud Data Flow, and it will be the exact same artifact, will run the same way.
So basically, when you go into the demo repository and take that custom module and just use Maven, package it up via Maven, you basically just get the jar artifact. Within Spring XD, you bring up your Spring shell and Spring XD shell, and basically just upload the module, just upload the jar file, say it's a job, and give it a name, and becomes available. So then you can basically do get the listing, module, list, tab completion here, and then basically you have your, here we go. MySQL to HDFS job. So that's there. So let's create the corresponding stream for that. Basically, what I need first is create the stream. So stream, where do I have it? I had it earlier. Stream create. Let's take it from here.
Do a clear or hit enter a few times. That bottom line isn't showing up on this screen.
Oh, it's not. Wow. Okay, sorry. Let's just.
Or you can reset the window, whichever one you.
Can I make this thing a little bit? Does that work?
Much better.
Cool. Let's create a stream. So in this case, I'm just creating the job create, does the deployment, and then it should deploy the job. Hopefully you don't see anything in my thing. Yep, got it in there. So I'm running it right now as a single node instance. So now I have the job, but how do you get stuff into the job? So in this case, I'm doing create an in-HTTP stream. All that does is basically use the HTTP source, and then basically have I can trigger basically my job using the queue job and then the name of my batch job that's being deployed. So basically now it's listing on the default port. So I could literally trigger jobs, as is. But I would also like to know when it's done. So in this case, I basically do, let's start simple. I basically just put out all I want to do is log something out when my job is completed. I just use the log sync and deploy that, good to go. So what I also like is get me some email notifications. So I can slap another tab on this thing. And basically use the mail sync. So just same mechanism. Tap into my batch job, get job status updates on the entire job execution. You could also tap into finer-grained notifications as well. So if you have multiple steps, etc., step executions, etc., you can hook into those as well and do stuff. So what happens if I post this thing? Yep. All I need then to do is basically, I'm kind of very simplistically, literally nothing in there, triggering at the posting to the HTTP endpoint that I had created from the HTTP source. Everything should, yep, it's completed, and my stuff should show up in HDFS. Oops, where's my Hadoop? Should show up under where did I put this? I'm drawing a blank here, but it should be there. Unless something, let me check up. We get the job notifications here. So
he didn't trust the network like I did.
Yes, I did not trust the network. So this one is actually kind of cool. So if you ever need to work on your email notifications, a fake SMTP server is a lifesaver if you have to deal with crappy networks and like instance response. So basically, I get the job status. I also got which execution ID was executed. So that's just an example of how you can integrate batch and into a streaming environment like Spring XD, and then also with the refinements that are going on then with Spring Cloud Data Flow, you have basically similar integration options to integrate batch and integration components into a distributed flow. What else? Sure. Yep.
So one thing to note with the Spring-specific ecosystem, we looked at Flink, we looked at Spark, we looked at Spring Batch. Obviously, Spring XD in the Spring Cloud Data Flow is built on the Spring ecosystem. One of the interesting things, though, is the fact that on the Spring side, you get the consistent programming model. So if you want to use Spark, if you want to use Flink, if you want to use any of those other streaming solutions that were on that big logo slide, the problem with, one of the issues with that is the fact that if you learn how to use one of them, congratulations. It's not like you can transfer that knowledge then to any of the other ones from a programming and API perspective, or most of your other systems in your enterprise. Whereas on the Spring side, you're already probably writing Spring Batch code or Spring MVC code, or those same Spring paradigms transcend whether it be batch, integration, streaming, etc. And because of that, you can also share code between the two options. You can write the same service and consume it from a streaming API by wrapping it as a processor, let's say, or you could wrap it as an item processor and run it in your batch application. So you can share business code so that it's not tied to any particular solution.
And you can also, I think, a big takeaway here for the Spring ecosystem is you can kind of like tailor it to what you need, right? So if you want to, just want to embed batch into your application rather than run it separately, you can. You can just treat it as a library if you want to. Same with Spring integration. If you just have a very if you have a streaming flow, but it doesn't necessarily have to be distributed, or you want to have something really super custom, just use Spring integration. You do that. If you use its repository of communication modules, etc., extensions, etc., you can do that. Treat it as a library if you want to. Integrate batch and integration. There's a Spring Batch integration module that you can basically use to integrate basically for scaling purposes. Notification list, notifications via messaging, extend the batch model there. You have that option. So you have Spring XD. So you can basically organically grow your needs for your applications within the Spring environment, which I think is a powerful concept there.
Very true. Very true. So while batch is old, if some people consider it crusty, it's not cool. Batch has lasted because it makes sense. It's evolved over the time to be able to integrate in these various solutions. It is a programming paradigm that we feel, and hopefully we've convinced you, is still relevant in today's enterprise. And we also hope that we've shown at least a little bit that Spring XD is in Spring Cloud Data Flow provides a bit of the best of both worlds. You can write the same code, run it in either paradigm, move back and forth between them, and so forth. Questions? Thanks, everybody.